So here are our conclusions. So the number operator, so n is called the number operator because when it acts on an eigenstate, it gives as an eigenvalue a number, and this number is an integer. So n has a name, a number operator. And the full justification of why it's called the number operator will be given shortly. Number two is that a dagger is the raising operator because it raises the eigenvalue of a state by 1, and A is called the lowering operator because it decreases the n eigenvalue by 1. The energy eigenvalues are En is given by n plus half times h bar omega, or in other words, En is going to be the lowest ground state energy when n is 0 is half h bar omega. The first excited state is going to have 3 halves of h bar omega, and then 5 halves of h bar omega dot dot dot. So this is E0, this is E1, this is E2, so on and so forth. And something that we mentioned before is that the difference in consecutive energy level is given by this constant value h bar omega. And as discussed in the previous lecture, we can approximate the intermolecular potential roughly, using the simple harmonic oscillator potential. What do we mean by that? So if I look at a typical intermolecular potential or interatomic potential, then, if this is the distance and this is the potential, then usually it has some form like this. And so what we're doing is that we're approximating the potential near the minima by the harmonic oscillator potential. And over here, the energy states are given by these energy states. And so they're the low-lying energy states. So another way of looking at these is to basically say that these energy states are evenly spaced. So this is say E0, this is E1, this is E2, this is E3, this is E4. So if we have an atom or a molecule, these are the low-lying energy states, and the raising operators, take you in that direction, and while the lowering operators take you in that direction. And so, we see that the difference in each in consecutive energy levels at h bar omega. So this, motivates the interpretation that we can use the simple harmonic oscillator as a way to, approximate the situation where we have an atom which is going to absorb a photon whose energy is given by h bar omega, and then as soon as it absorbs this energy, it jumps from a low energy state to a higher energy state. And similarly, when it jumps down into a lower energy state, it gives out a photon of energy h bar omega. So this motivates the name A as the annihilation operator, and that's because it's annihilating a quanta of energy. On the other hand, a dagger is known as the creation operator because it is creating a quanta of energy. In quantum field theory, the simple harmonic oscillator becomes the prototypical model for a quantum field whose excitations are given. It becomes a model for a quantum field whose excitations represent particles, and therefore, there, instead of these excitations of h bar omega being photons, they represent some generic particle. So that's another reason why we have these names, which are more often used in quantum field theory. And because of the particle interpretation, the operator n measures the number of particles, and therefore this is called the number operator.